Hello, good morning. You can hear me? My voice is coming clear?
Good morning, sir. Yes, sir.
Okay, let me start. Today I have a call at 11, so I have to quickly finish. So, yesterday we have discussed Python for, how to prepare, how to check the data, how to understanding data using descriptive statistics. We have seen median, all the descriptive statistics. Then we also seen how to visualize the data using, visualization. There we have seen Matplotlib and Seaborn, some of the advanced visualizations also. Today we are going to see how we can prepare. As we already discussed, the most of the time in modeling will take for the data preparation. Today we will see how we can prepare the data. How to prepare data for modeling. So we will see some of the tasks like how to find the missing value, how to find the outliers, how to do the standardization, normalization, transformations. So then, if possible, we'll also see the logistic regression and regression output. Then Monday we will do the project, big project, complete machine learning pipeline project. Okay. As I told you that now, you know, no, like I keep on telling that Python is basically has a lot of wonderful packages because yeah, Python is basically wonderful packages. So there has been different packages there for the different kind of things. So if you see on that part there, NumPy is basically for numerical Python, which can help to access or manipulate arrays. Pandas for to data frames, reading data, slicing, dieting, filtering, selecting everything. And Matplotlib is basically for charts. Similarly, for most of the machine learning tasks modeling, we have scikit-learn. Scikit-learn is also one kind of package which contains a lot of modules of models and also functions which support the modeling. So if you want to run, if you want to evaluate, if you want to hyperparameters, all the things, whatever we discussed on the theory, all those parameters, all those functions will be accessed by using scikit-learn package. So which is basically one of the most popular used Python package for um, machine learning. Okay, so that's what I wanted to say. That so here, if you see, first I'm importing library, import pandas as import. These are the default. NumPy as NP, Seaborn as SNS, Matplotlib as plot, and I am reading Titan data, and I am also seeking df.shape how many people are there and head top 5 rows also. Okay, this is preparing data for analysis. So if you do that, it's running. That's right. This star means it's running. So it ran the data and it first given the data. Actually, we need to do individual. So once we read the data, if you want to see how many rows and columns, shape. So we have 891 rows and 12 columns. And if you want to see the data by using head function, we'll get this thing. Okay, that's it. Then if you want to see any missing value, because missing value is one of the interesting, one of the frequently happen thing in the real time data. So because we may not get all the values, so sometimes missing values do occur. So in order to see the missing values in Python, the function is null. Is null. So is null is basically give whether the particular response is missing or not. So if you want to see how many people are there in the missing value, what we need to say, you need to basically find the sum of the people who's who is null. So that will give the number of people who are missing data. Then if I divide it by length of data frame, then I will get the percentage of people who are missing. So that's what it does. So in order to see the missing value, what is the command? Is null. Okay, df.is null. If I do that, so this is how it will give. So for each and every variable, it will give the percentage of cases which are missing value. So passenger ID, survivor, there is no missing value. Class, there is no missing value. But yes, there are 19% cases are missing. Cabin is 77% cases are missing. And embark 0.22% cases are missing. This is how we will see. But as I told you that, it's always difficult to see from the numbers. That's why there is a heat map is also there. It will also give the missing values. So that's what it does. So some people wanted to see missing values also in some kind of picture, some kind of diagram. So that's what it does. So there is a function there, which is there in Cbon. What we are trying to do basically sns.heatmap. df dot Israel, and this is what print. We are basically see missing value. If I do like this, so this is what it will give. If it is missing value, then it will give. So these are the cases which are missing value, and cabin is the missing value. Rest all there is no missing values. That's how we need to see the missing value. Then once we have the missing value, we already discussed how to impute the missing value. There are three kind of showing the missing values. One, if it is like missing value is more than 50%, we can exclude. That's why we are excluding that embark some variable. But if it is continuous variable, then how do we replace the missing value? Either we will replace by mean or median. If it is categorical value, we will replace by using mode. That's what we are doing here. We are basically trying to impute. So what is the variable we are referring? Df dot age, fill NA, fill missing, ops in the same variable with mean in place true. In place true means it will override the same column. So what this we are trying to do here, we are trying to basically replace the missing values with the mean of the valid cases. That's what it does. Df of age dot fillna is a function which basically essentially fill the missing value with d of age of mean with valid cases. Similarly, in the cabin also we are replacing with mode. Once we replace the mean with mode, then if I do this kind of chart, then we'll see what is the machine. Now we already seen in the chart, only cabin is there, this is there. So these two variables we are missing now, age and cabin. Age we are replacing with median value, cabin we are replacing with mode value. Now we will do the similar kind of chart, then we'll see is there any missing values or not. See, there is no missing values now. Now our data is clear. That's how generally people will do. Other than that, there is a modeling method is also there that very rarely people will use. That you can see later. Now, next in the data preparation, we also discussed about the outliers. So what is the best way to find the outliers for the continuous variables? We already discussed the best way for the finding the outliers for the current box plot. So age is the continuous variable. Now let's see. So what we are doing, plot dot box plot df of age, then show. So this is what we are doing. If I see this, is there any outliers are there here? There are outliers. So this is basically Vishkar. This is quarter 2, quarter 3, quarter 1, interquartile range. Quarter 3 plus 1.5 into interquartile range this mark. Quarter 3, 1 minus 1.5 into interquartile range this one. Any value which fall outside the Vishkar, below Vishkar is the outlier. So then we already discussed how can we do the outlier. If any value which is greater than which is higher side of the outliers will be capped by the 95th percentile, lower side will be capped by the 5th percent. So that's what we are doing. So we are doing what we are doing. We are basically calculating that value. I love quartile value you are getting 95, and here what we are df of location, df of age is basically df of quantile 0.05. So here if what we are trying to do basically df dot location, df dot age, if it is less than 0.05, that means if any value which is less than 0.05th quartile, then what we are doing, we are putting them into 0.05. That means we are capping it to 5th quartile, correct? And if any value which is greater than 95th quartile, then we are putting into 95th quartile. This is the capping method we discussed, correct? That's what I am doing the same thing here. If I do that, now if I say what will happen, there is no outliers. So the values will be no. So this is how we need to do it for outliers. Okay. Now, similarly, binning. What is binning? Basically, binning is basically this is all we discussed under pre-processing data. You need to see the notes also. When you are basically have your continuous age is there, but age is basically ranges from 0 to 100. Because if you consider age 0 to 100, sometimes what it does, it may not give the variance because of various columns. So we need to condense them into various groups. To do that, what we can do, we do the binning. Binning is basically converting the continuous variable into nominal variables like age 0 to 10, 11 to 20, 21 to 30, 31 to 40. Like we will convert them into various groups. That process is called binning. So that's what we are doing here. Simple. We are just making five columns. That's what we convert them into the binning also. Okay. Then if you see the age distribution, how can if I want to see the age distribution, how to plot the chart? Tell me. If I want to see the distribution histogram, how should I do this plot? Df dot hist. So if I see histogram, so if you see this data is somehow positively skewed, correct? Positively skewed. Most of the values are toward. So we already discussed transformations. When we are discussing with the transformation, we already discussed transformation due to the shape, transformation due to the units. So due to that shape transformations, we will use the log transformation. So log transformations is basically try to transform the shape of the distribution. So that's why here it is positively transformed. So sometimes what will happen if you consider this age variable as it is and try to build the model, because the data is positively skewed, you may not get the good results. So in order to remove this thing, what you need to do, you basically need to reduce the skewness. How do you do that? Using the log transformation. That's what you will here do. So here you say df of age log transformation is basically df of age apply np dot log. That means that np is basically from numpy. So that's how it will give. This is what. Now if I plot, let's see how the distribution will change. Then it somehow became normal distribution. See, that is what it is, the difference between these two. So the units are condensed such that it somehow reduce the distribution. That's how people will use it. So so basically transformations, log transformation, e power transformation, log of max plus 1. See, because your log 0 is log 1 is 0. That's why log of max plus 1 people will do. So when you wanted to do transformation which can reduce the distribution of the variable, then people will use the log transformation. Then there is also another kind of transformation we have discussed, which is the standardizing. What is the standardization? When the variables are in the different units, we need to standard. So that's why in order to do the standardization, what we need to do is basically reduce the we need to put all the variables in the same time. That's what standardization. To demonstrate the standardization, basically I am reading a data file called diabetes.csv. It has some 5-6 variables. We'll see what are the variables. And here what we are doing, we are reading the data, we are seeing the shape. Let's see. And we are seeing is there any missing one. This is the data for diabetes. We have number of pregnancies, glucose, blood pressure, skin thickness, insulin, BMI. Here if you see the number of pregnancies is also variable and glucose is also variable. So these two different variables has different kind of units. That means if you try to build any regression or any kind of model, this higher volume value is try to overcome the regression, because regression is basically linear combination. This value into this plus this value into this. Because there is a high number is here, it will try to reduce the effect of this variable. That means predominantly dominate the variable. So in order to avoid that, what we need to do, we need to put them into standard units, same units. That's the one reason. Another reason is tomorrow, once you build the equation, if you want to find the relative importance between pregnancies and glucose on the diabetes, you need to put them in the standard. So you need to put them in the same units. That's the reason we need to do the standardization. And we already discussed the data standardization. There are two types of standardization and normalization. Standardization is basically we are trying to make mean 0 and variance is 1. Normalization basically we wanted to make minimum value is 0 and maximum value is 1. That's why we have two functions of standardization. In the standardization, the formula equal to x bar minus mean by x bar minus mu by sigma by root n will give the standardization, which makes your distribution average as 0 and variance as 1. And another transformation which is called normalization, in which actually we are making minimum as 0, maximum as 1. The transformation is actually x minus minimum by range into 100. Other than this, there are some other transformations also there, like Box-Cox transformation, Cox transformation, different transformations, where they try to make all the independent units are the similar kind of distributions. So we are not dealing that. We are basically dealing with normalization and standardization. So for that, we read this data. So this data is basically diabetes data. And if you see the type of the data, and if you see is there any missing value, yes. So here we have glucose is the missing value, and BMI is also missing value. Once you have a missing value, the same step we will follow. DF of glucose fill now with mean, and we are basically making no missing value. So now this is the missing value. But the problem is basically we have number of pregnancies is 1 unit and glucose is 1 unit. I mean BMI is another unit, but number basically the magnitude is different. You need to put them into the same. So that's why what we are trying to do is basically, this is how we can take the value. What we are trying to do is basically, we are basically taking, isme actually outcome variable is the last one. We never transform the outcome variable. So what we are trying to do is basically, we are taking all 8 variables, pregnancy, glucose, these are all the input variables, correct? So except output variables, all are the input variables has the different units. Now, in order to make these are the comparable, we need to make them as the standard, standard. We need to remove the units effect, or you need to make them into the standard. So that's why what I am trying to do is basically, I am saving all these 8 variables into another variable that is called x. X equal to array dot colon means all respondents, comma 0 to 8. That means first 8 variables I am putting as x, and last variable I am putting as y, which is dependent variable. Now, which ones I need to basically standardize? X variables. Further, there is a function which is there in scikit-learn. So stand scalar is a function which basically do the scaling, standardization of the scaling. So when I say stand scalar dot fit x, it will take all the variable x and do the standardization, and that variables basically scaled in the rescaled x. So rescaled x is scalar dot transform dot x. That's what it does. Then I am basically saving this 5 rows. So that's what, all these variables are now standardized. So if I want to save this data, same, I can save the transformer data also. Now you can see the transformer data here. Anyway, transformer data in the location. That's how. So now all these variables are standardized. Mean equal to 0, standard deviation equal to 1. Let me show. If you transform, all the variables will be transferred. If you see the mean equal to 0, obviously, the standard, if you calculate average, not like that, because we have done like this now. Every variable, if you calculate average 0, I mean this is almost 0. E power standard deviation is basically, that's how it does. All the variables will have mean 0 and standard deviation 1. That's what it does. That's what standardization will do. And other than that, we have two other things we have discussed. One is the label encoder. So if the data is captured in text, basically, then text has to convert into the numbers. For that, we need to do the label encoder. Label encoder is if your data is male, if your data gender is coded as male and female. So male and female cannot understand the computer. So first you need to convert them into male as 1, female as 2. So for that, we will use the label encoder. Once you've done the label encoder, we will convert them into dummy variables. We have discussed the dummy variables concept also, because we cannot use male 1, female as 2 and consider that as a continuous variable, because it doesn't have any theoretical contribution. That's the reason all the dummy variables will be, all the categorical and nominal variables will be considered as dummy variables in the modeling. And there are different kinds of people. People sometimes use label encoder also. Like if you say, there will be some order is there. So user and non-user. Sometimes people try to give user as 1 and non-user as 2, and still also they can use. They will give some kind of numerical weightage. If you can handle categorical variable by giving some kind of numerical weightage, then you can use the label encoder. So when I say label encoder, I know I am doing a study where females are, I want to give some kind of weightage for females. Then what I will do the label encoder. I will convert male as 1, female as 2. And if I consider, then if I wanted to give subjectively as a weight to the categorical variable, I can use the label encoder. Otherwise, what we need to do, if you don't want to give any weightage to the categories in the categorical variable, then you need to use the dummy variable. That means male is one variable. If respondent is male, 1, 0. If respondent is female, 1 and 0. That you will create the two variables, label encoder and dummy. But most of the times we will use the dummy variable, dummy coding. Okay. So that's what it does. Label encoder means CQS. So basically C0, Q is 0. Yes, there are 3 variables. That's why this 3 variable S, it basically categorizes S equal to 0, Q equal to 1, C equal to 2. That's how all the numerical variables will be converted into this node. Now, if you wanted to, there is some kind of relation, and if you wanted to give numbers, you can use this code. Otherwise, if there is no number, then what you need to convert this variable into 3 other variable. C equal to one variable, Q equal to one variable, S equal to one variable. If respondent C, then 1 0. If respondent Q 1 0, respondent S 1 0. That's how people will use different kind of coding. Label encoder is one there. Dummy coding is there. There is also one more called target weight, target coding. And there are different kind of coding, and it all depends upon the business need, how you wanted to interpret it. But ideally, the default suggested one is the dummy variable coding. You need to create each category as separate and do the modeling. Okay. Then the last one is basically this is what dummy coding. Now we have the P class. What I am trying to do, get dummies means P class has 3 variable. I will get the 3 variables. If you see P class, I will get the this thing. Now if I see D of P class, you have 3 variables. And in actual 3 categories, if I say D of, now you see what will happen. All your P class variable get the 3 variables like origin 1, origin 2, origin 2 like that. So it will basically get the 3 variables. Basically every dummy is get 1 variable. So these are all the things you need to do before you doing the modeling. Okay. So what we discuss is now we need to see how to find the missing value, how to remove the missing value, outliers, and then normalization, standardization, all those things. Okay, this is how people will do in the preparation stage. These are not, this is what is there in your syllabus, but this is what people spend most of the time in their analysis on the data preparation. If this is done, we'll connect at 10:35 and we do one regression, one small project, regression, logistic regression, and decision trees. That's all. Okay. Any doubts?
No, sir.
If there is no doubt, I am just stop sharing and recording this. Okay.